All right. Welcome, everyone. Thanks for being here. This is a session on Google Cloud APIs, data ingestion, management, and analytics. My name is Kalyan Pamarthy. I am a product manager in the Google Cloud Healthcare group. I manage the Cloud Healthcare API, which is a large portfolio of services for FHIR, HL7v2, DICOM, DID, and others. I'm joined today by Dharmesh Patel, who is a manager in our solutions team for the Google Cloud Healthcare team as well. And he and I work very closely on both the product and solution side of FHIR use cases. So there's three things that we wanted to talk about today. First, I'll give a quick overview of the Google Cloud Health API and the set of capabilities we need for fully managed FHIR servers. I will talk briefly about a few special features that we have, including ones that we've launched recently and it's part of the feature spotlight section. And we'll spend the last 10-15 minutes with Dharmesh giving us a demo of an end-to-end use case for FHIR. Okay, let's dig into the FHIR APIs in Google Cloud Healthcare. So a Google Cloud Healthcare API is a fully managed set of cloud services, primarily targeted towards builders and solution developers to accelerate healthcare solution development in the cloud, right? So we're the primary API surface in Google Cloud for bringing in, storing, and managing access to the data. So we've been in GA for more than a year, have been in beta even before that. And so we've been building FHIR, HL7v2, and DICOM services for a few years now. And at the core of our healthcare API is the set of fully managed standards-based storage and API capabilities, right? So we have a fully managed FHIR server, as well as an HL7v2 server and a DICOM server. A core part of our healthcare API is the fact that it is leveraging a lot of the Google Cloud privacy and compliance capabilities, right? So things like HIPAA, HITRUST, they're all baked into our fully managed services. We're also continuing to build, and we've been doing this for the past few years, on value-added capabilities in addition to the core FHIR, HL7v2, and DICOM servers, and things like data de-identification, data transformation, etc. We're also very well integrated with the larger Google Cloud ecosystem, and so we find a lot of customers working with analytics and FHIR, for example, using Google BigQuery, ML use cases with our Google Vertex, which is our cloud AI platform, as well as building solutions using technologies such as Cloud PubSub and Cloud Functions. And then we also have support for smart and FHIR applications with the healthcare API. We have a broad range of capabilities in our FHIR server, as you would expect. So we support DSTU2, STU3, and R4. We have a set of capabilities for importing and exporting data. So you can bring in FHIR data from other systems, load them into our managed FHIR server. You can also export to BigQuery for analytics. So I mentioned briefly about that before, both in streaming and batch. And you can also do a FHIR bulk export. Today we support that at a system level, but we have other capabilities coming shortly. And again, as you would expect from a FHIR server, we support all the standard CRUD operations for creating, updating, deleting resources, as well as conditional create, updates, and deletes. We're continuing to build on the set of FHIR operations we support. So we've got a fairly extensive set of capabilities around FHIR search. We support patient everything, observation last, and executing both batch and transaction bundles, as well as some capabilities of for translation between various value sets. This is primarily for terminology server use cases. As I mentioned before, we are well integrated with other Google Cloud servers. We use PubSub notifications and any changes to the FHIR server. This is very widely used in building applications where customers need to track changes to the FHIR data and take some downstream action. We're also integrated with our de-identification services. I'll talk more about that in detail in a few slides. And we support custom profiles as well as some standard profiles for FHIR as well as DICOM. Okay, so I'm going to jump into a few feature spotlight areas. Today, I wanted to cover a little bit about our data transformation tools, FHIR profile validation, FHIR custom search, de-identification, and a new UI that we launched a couple of months ago to explore FHIR data in your FHIR servers. Okay, so data transformation tools. I mean, we've been investing in data transformation from other data standards and data formats into FHIR for quite a long time now, right? So we talked extensively about our HL7v2 to FHIR transforms in the last 2 DevDays. So we've got open source transformation mappings that we've put out there for HL7v2 to FHIR. It is based on the mappings that the community has given us, but we've also incorporated some learnings from our implementations of HL7v2 to FHIR at large health systems. We also have a CCD to FHIR mapping, and we're going to explore that in the demo today. And these are all open source, so I've included a link here of our GitHub, and you can go pull those mappings and start implementing them. We've also had a DICOM to FHIR connector for about 9 months now, and so we talked about it at last DevDays. This is about connecting DICOM studies through the imaging study resource into FHIR. And so many of our customers are thinking about connecting the clinical data with imaging data, find value from this connector. So you can go take a look at all of these at our GitHub link. So the way our transformations work is a combination of a simple configuration-based mapping language and a workflow engine that runs the mappings, right? And so we started this a few years ago and settled on a simple configuration language. We call that WHISTLE, but it's essentially a set of mappings from a source specification to a destination, right? And so if you go to our GitHub page, you will see a whole bunch of WHISTLE configuration maps. And there are a lot of mapping languages out there, FHIR mapping language being one that's also gaining traction right now. So we're tracking the other ways to do this as well. But we've done development about, for example, supporting repeated nested structures, mapping terminologies, and all that for making transformations between these various data standards fairly easy, and for someone who doesn't need to write a lot of code to implement these mappings. And then there's 2 ways that you can run these data transformations. One is integrated into our Cloud Healthgate API. So this is a set of managed methods where you can use either when you're importing data into FHIR from our object storage, Google Cloud Storage. You can also export. You can also do a transformation while exporting it from our FHIR servers into, for example, BigQuery. And we also have a managed HL7v2 store, as I mentioned before. So if you are storing data in the HL7v2 server, you can also set up transformations, both batch and on the fly, to transform data into FHIR, right? All of these are using the same WHISTLE configuration mappings that I showed in the previous slide. The other way a lot of our customers do it is incorporate these mappings into their own infrastructure. And you can do that using Cloud Data Flow, which is our workflow automation offering from Google Cloud. It's based in Apache Beam. So you could set up pipelines as part of your data ingestion transformation infrastructure to run these transformations and land data in the FHIR server. So the next feature that I wanted to quickly talk about was FHIR profile validation and implementation guide validation. I mean, this is a very common use case with CMS, ONC interoperability rules, as well as with clinical data validation for US core. So we've got features on our FHIR store where you can set up a set of profiles, or you can set up an implementation guide with a collection of profiles the search parameters and value sets. And once that is enabled on a FHIR server, anytime a resource is updated or created in our FHIR server, we automatically validate that against the profiles that have been set up, right? And then we've got a bunch of functionality around what we support in those profile validations. For example, slicing, checking for min-max constraints and others. This is fairly easy for anyone to set up, right? And then typically our customers set up either the Kalyan blue button IG or the US core IG to enforce those particular constraints on the data. And once this is set up and it's running, there's no need to be calling any specific validation operations, and all the errors are written out into our cloud monitoring, and this helps quite a bit in setting up the data infrastructures and QA process as well. We also have support for the $validate operation in case we need to be able to call or check for validation on a single resource, and so we validate against the profiles that are set up in the store, but also the profiles in the meta tag in the resource. We will talk a little bit about this in the context of US core validation in the demo. Okay. The other feature that we've recently launched is the ability to be able to do custom search. Again, this is important in the context of CMS ONC interoperability rules, but also DaVinci profiles and other use cases. And so we now have the ability to enable FHIR search and parameters that are beyond the ones that are defined as standard for each resource. Again, setting them up and running it is fairly simple. You create one or more search parameter resources, trigger an operation to reindex the store, and once that's done, all the search parameters are ready to be used. So fairly straightforward. We find a lot of customers finding value in this feature. Okay, and then the next spotlight feature is our FHIR de-identification. And so, as many of you know, de-identification is the process of removing PII from data, but also trying to retain the value in that data so that it can be used for analytics and machine learning purposes, right? And typically, we find a lot of secondary data use cases where data is either in FHIR or DICOM is driving real-time clinical applications, but also needs to be de-identified with some very specific configurations, right? So, like for example, names redacted, times shifted by a certain amount of time, and all these are so the value is still retained in the data to do analytics, machine learning, but there is no personally identifiable information, right? So typically these workflows are large-scale analytics or AI ML model training and prediction tasks. So our healthcare DID has been available for, again, a couple of years in the market. We continue to improve it and invest in it from a machine learning standpoint. And our cloud healthcare DID is built on the cloud data loss prevention offering that we have for general purpose data redaction and de-identification. So what you're seeing here in the animation is an example of real-time data de-identification, right? This is with our cloud DLP offering. And so on the top, you'll see as we're typing text that has identifiable information, this automated de-identification happening. For example, Raven is stripped out and replaced by person name. Ibuprofen is replaced by FDA code. The credit card number is replaced by a random number, as well as date of birth. Social security number is obfuscated for part of it, but the last four are saved. So a lot of this is configuration driven. And our cloud healthcare DID service builds on top of it, right? So what we've done is taken that and added additional capabilities or medically tuned models, so we can identify medical information in that, but also think about HIPAA, safe harbor, and other considerations that our healthcare customers might have. So what you're seeing is an animation of an example clinical note in a text format. We're identifying the various entities and their names, medical record numbers, dates, etc., and are choosing to either replace the information or redact the information. So that's just a quick animation example. We've got a lot of options in our healthcare DID. So on a field level, you can decide whether you want to retain the field, which is the option to skip, whether you want to transform the field, or whether you want to conditionally inspect and transform the field, right? And so, in the case of structured data such as FHIR, this is primarily about selecting the fields and transforming it. And with transformations, you have a lot of different options. You can redact the text, replace them with some special characters. You can use a customer-defined chosen crypto hash to replace PII with the hashed information, with the value from the hash. And we also support a set of default configurations aimed at making it easy for customers to satisfy safe harbor requirements. So here's an example of an original FHIR record and what happens after it goes through our de-identified de-identification process, right? And by the way, all of this is integrated into our FHIR servers. So you don't, as a user, don't have to set up any special infrastructure or write any cloud functions or any other code for this to happen, right? Just a configuration on a FHIR server, check a box, and start the de-identification process. So in this example, we're showing a few different things happening with the data, right? So for example, if you look at the address on the top left, city, district, and line, we've chosen to redact that information. And this is part of a configuration. You can choose to do something else with those set of fields. For birth date, what we've done is actually we've date shifted it. This is one of the features that we have in FHIR de-identification, is being able to shift the dates while keeping a chronological order. And this becomes important for analytics and machine learning use cases. In this particular example, we've decided to retain the gender. So this is an example of skipping a certain field. And if you go to the bottom, you'll see that we've chosen to replace names with a special format, right? So this is person_name. So this is just to give everyone a flavor of all the different choices that you have. This is for FHIR. We do similar DID with DICOM as well, both for DICOM metadata and also burnt in text. The reason I wanted to call this out is going back to our FHIR DICOM connect. This is an option for us to bring so that identified FHIR and DICOM data is driving clinical applications, but the de-identified FHIR data and the de-identified DICOM data can now be linked together. So you're now creating this consolidated record for analytics and machine learning, drawing from both the imaging as well as the clinical data sources. This is becoming increasingly popular as we see customers trying to combine the two types of data. And then lastly, the feature that I wanted to call out was a new UI tool that we launched a few months ago. It's called the FHIR Viewer. So we're seeing a lot with our implementations that there is a need for being able to quickly explore what data is in the FHIR server, primarily for verification, validation purposes, right? And a lot of the enterprise architectures have pretty intricate data transformation pipelines. There is a lot going on, and you want to quickly assess what's happening at the end of that pipeline, and whether the data that's landing in your FHIR store is what you want it to be. So you can obviously explore your FHIR store with all the API calls. So that is just part of the FHIR standard. What we've tried to do is create a browsing and search interface on our FHIR servers that just makes it really easy for non-developers to explore the FHIR store, obviously with the right permissions, search for specific resources, do spot checks, look at what implementation guides have been enabled on the FHIR server, and look at, for example, what custom search parameters have been set up. So there's a lot of functionality here that we're trying to give our customers as they're building their infrastructure and leveraging the data in the FHIR server. And Dharmesh is going to use this quite a bit as we go through the demo. Okay, so all the Cloud Healthcare API, like I said, has been in GA for a while. There are lots of features we're adding in preview. We'd love for everyone to look, give us feedback. The link is cloud.google.com/healthcare. So just a lot of user guides, architectures, and information out there on how large payers, providers, as well as digital health companies are using the fully managed Google Cloud FHIR servers. With that, I'll hand it over to Dharmesh for a demo, and then we'll come back for questions. Dharmesh, are you on?
Yes, I'm on. Thank you, Kalyan, for walking us through all the features. Let me share my screen for the demo and quickly bring in my presentation. If you cannot see my screen, let me know and I will.
We can see your screen, Dharmesh. Thank you.
Awesome. Thank you. So, so in this next 10 to 15 minutes, what I'm going to cover is some of the key features that Kalyan has just explained. We're going to walk through that. We're going to execute some of this, and we're going to look at it from a very deep perspective. So number one is we'll configure a FHIR server in Google Cloud, and we'll see how easy it is to configure a FHIR server in Google Cloud with maybe 2 or 3 commands. You can do it, you can Terraform it, and you can create it. Then we'll look at some of the FHIR implementation guide validation functionality using $validate. We'll validate a patient resource against US core profile, STU1, and then we'll also look at the support for custom search parameters. And custom search parameters are those search parameters that are defined by users in the FHIR search as FHIR search parameter resources by defining the search expressions, and then those are imported into the FHIR server and they are executed. And we'll look at that. We'll also look at a feature called streaming export to BigQuery, how you can connect Google's FHIR server with Google's BigQuery, which is a data warehouse. And when you insert or do any mutation on the FHIR store, those data is also available in the BigQuery. And then we'll look at it, how you can ingest data, CDA data, which is a clinical document architecture compliant CCD records as an XML file, how you can ingest it into Google Cloud, and how can that be harmonized into FHIR. And finally, if time permits, we'll look at the de-identify and bulk data export. We have looked at de-identify and bulk data export in the last November FHIR DevDays, so I don't want to spend so much time on that, but I'll revisit it just for the sake of completeness. Also, last FHIR DevDays, we covered ingestion harmonization of HL7 v2 to FHIR, which I would like to remind that it is already supported. This time we're going to look at the CDA to FHIR. So let's dive deeper into the first one, which is configuring a FHIR server in Google Cloud. So it's basically, you can do it in 2 ways. You can do it using a user interface like this. You can create a data store. You can first create a data set, and then inside the data set, you can create a data store of type FHIR, and it will let you store the FHIR store. So you can do it using user interface, but for today's demo, we will do it using the command prompt because I like command prompts. And also it is quite easy to do it using command prompt. Hold on, let me get my other window out. I think I am hiding it behind this. Give me a minute. Yeah. Okay. All right. So I'm going to execute all those queries here. So first, we are going to create a data set in Google Cloud. Essentially, what I'm doing is I'm providing an HTTP post call to create a data set in a project called HA Portal. In US Central 1 is the region where this data set with a data set ID of DevDays DS will be created. And let's make sure it doesn't exist there. And I see there's nothing here. So it should be fine. So this is this indicates that the call was successful, and we should see the data set being created here. We can do exactly same thing using the FHIR browser over here, the healthcare browser. So this was the new data set that we just created. And then inside this data set, if you see there are no data stored, and data store could be created using the UI like this. You can provide the type of the data store that you can create, FHIR, HL7v2 or DICOM, and then you can provide an ID and hit the create button. We can do it that way, or we can create it using an HTTP call using the APIs we have. And this is the API to create the Firestore. And in this case, I'm providing a Firestore ID of R4FS, which will allow me to create the Firestore into the data set we just created. And this data set is currently of type R4, FHIR version R4. And if I go back here, I should see that Firestore here. Now that I have Firestore, the FHIR viewer that Kalyan mentioned before, you can open the FHIR viewer on that Firestore, and obviously we just created this FHIR server or a Firestore. There is no data in it, right? So if I look for patient, I don't have any patients in this today, right? It's completely empty. Anyway, so let's go ahead and import some FHIR data, and then browse the FHIR data in the viewer. Before we do that, we can do some other operations to change the Firestore configuration. So for example, there is a patch command. The patch command will let you update certain configurations on the Firestore if you want to, and we'll be using patch over and over again to change the same Firestore by adding all the validation configuration, all the streaming configuration, and so on. So I just wanted to introduce this patch command here, which basically right now I'm just enabling update create as a flag on the Firestore, which allows me to use put to create new resources, basically HTTP put. And then I can also execute a get on the Firestore to get the current configuration of that Firestore. So in this case, we have this Firestore, which has, and this flag was just enabled on this Firestore. So now that we know the Firestore exists, let's start an import operation, which is a long-running operation. LRO is what we call it. This operation essentially is import on R4 Firestore, and I'm importing a bunch of patients from a patient.nd JSON file, which I have already staged into a cloud storage bucket. And Google Cloud Storage Bucket is an object store from where we will read this file, and then we will ingest all the patients that are there in this ND-JSON file into this Firestore. And what it does is it starts a long-running operation, and this is the ID of that operation. So let's look at into the FHIR viewer, or sorry, the FHIR browser. What happened? Sorry, wrong click. Yeah, so as you can see, the create dataset was the first operation we ran when we created the dataset, and the import resource was just finished. And this basically imported all the resources. So now if I go to the FHIR viewer, right, and look at the Firestore R4FS that we just created, I should see a bunch of patient resources here. I have about 12 patient resources, and now I can examine those patient resources, the content of those resources, and so on, right? And this one I just created. So, and then if you look at the details, this gives you more details around the implementation guide, but there are no implementation guides found in this store. That means we have not enabled this store for validation yet, for FHIR profile validation. Now let's look at the FHIR profile $validate function. So what we're going to do is we're going to import an implementation guide, and in this case we will import US code 3.1.1 IG. We will enable that IG, and then we'll execute $validate on the store to try to insert a patient with $validate. So it will validate the patient resource before it is inserted. Then we will look at the configure search and we'll execute the custom search parameters. Okay, so first we'll have to import the US core IG. And again, this you can do it using the APIs today. We will use the same import command, which is an HTTP post call to our import resource, but this time we are importing all the IG resources that we have stored into a storage bucket. And let me show you that bucket real quick. Oops, wrong one. So I have all my implementation guides. I have downloaded it and stored it here in this bucket. And this is one of the implementation guide, which is US Code 3.1.1, where you have all the capability statement, all the search parameters, concept map, and the IGs stored here, which I'm going to import by running that command here, right? When I run it, it's essentially going to start another long-running transaction to import the data. And as you can see, the long-running transaction to import all the resources is just started. And once it is imported, those resources, all the FHIR IG resources that we saw here will be available in the store for us to query, right? So this is how we are importing the IG. The next, what we are going to see is once you've imported the IG and the associated resources, so IG is the implementation guide resource and then other sources, you have to enable those resources, right? So for enabling those resources, we have to patch the Firestore now, right? This time we are patching the Firestore and providing a validation configuration. And in the validation configuration, we are saying, hey, turn on the profile validation and use this as your implementation guide, which is the FHIR US Core 3.1.1, right? And I'm updating the validation config. Again, let's look at what is the state of that import. I think the import is done. So now if I go back to my FHIR viewer real quick, and if I refresh the details, I should see that implementation guide US Core 3.1.1 is now available in my Firestore, which was not there before. And I should see my resources here also. So if I now look at the implementation guide resource, I have that implementation guide resource loaded into the Firestore, right? With all the structure definition. I also have search parameters, sorry. Search parameters needed for or defined into the US core profile, like US core race is available here, right? So now let's enable this IG for validation. So when I run this patch, now I have changed my Firestore configuration by enabling the IG. So my Firestore configuration is ready for validation, as you can see. And then what we'll do is we will try to create an invalid patient resource, a patient resource that I already have on my box here. I will quickly go show that. I have these two resources. One is the invalid patient resource that's not valid as per the FHIR US Core 3.1.1 specification. And what is not valid, I believe, is this particular value for birth sex, which has to be male, female, or something, and then it is not applicable here. So it should fail if I try to do this. So now what I'm executing here, okay, hold on. Is another curl command to insert the patient resource, but this time I'm saying don't just insert my patient resource, right? This US core invalid patient resource. you also do a validation on it and validate it against this particular profile, right? So when I run this, it's gonna try to insert it, and obviously it was not valid, so I got a bunch of errors here. And this error clearly says, oh, US core race, there's an issue with that. There's also an issue with the US core gender, right? So now what we can do is we can try to insert a valid patient, and in that situation, when I do it, it should work. Now I'm inserting a valid patient, which is this one, which I already have on my VM. And so as you can see, a new patient was inserted. It's the patient Amy Shaw. And if I go back to my FHIR viewer and look at the patient resource, we imported 12 resources before, and this was the 13th resource that we just inserted, which is should be for Amy Shaw. So that's Amy Shaw's resource in the Firestore. And this time, if you look at this resource and the meta section of the resource, you can see that this resource conforms to the US core profile 3.1.1. So with that, I think we looked at up to the $validate. Let's do a configuration of the search parameter in the Firestore. So again, we'll go and look at the current configuration of the search parameter. As we saw before, we know that US core search parameter, US core race search parameter exists. So this is the search parameter resource which we pulled. And if you look at this expression in the search parameter, right, which is used to basically search, it's of type token, and it has the status of active, but it's on the code. I'm looking for the expression, which is, I think it's this one. Yeah. So I think what we'll do is we will import a new search expression, new search parameter into the Firestore, or update this one so that we have the right expression. There is no expression here because this was wrongly imported or something, right, before. So I have another US core search, US core race expression here, or search parameter here with the expression this time. And I'm going to insert this one or update this existing one with this new one so that I can use that for searching US core related fields. And what I'm trying to do is, let's say if I try to search on US core today, right, on my Firestore. So I'm doing an HTTP GET with the search query that I want to search for a race, and this is the code for the race. Actually, this should not be text. Okay, when I run this, I'm not going to get anything, right? I'm going to get everything. It's basically not working. It's returning all 13 resources. It's not doing any filtering on the race because the search parameter is not enabled on the Firestore, right? Okay. So now let's enable the first search parameter. So what we have to do is first we have to import the search parameter. And so I'm going to import this search parameter US core resource, which has the right expression and everything, right, into the Firestore. And that has imported the search parameter into the Firestore. And now I will configure the Firestore to enable this search parameter. So what I'm doing is I'm executing another post and providing the search parameter URL, search parameter URL, and I'm configuring the search. In background, what it does is it runs a long running operation to index your Firestore on this particular search element, and it implements that expression dynamically for you in your Firestore, right? So if you have custom search parameters, you can define that and enable it on your FHIR server. So this feature that's why very powerful. So now, if I execute the search query that we executed before for the race, and not the text, then this should return me only 6 resources, because apparently in my FHIR store, I have only, even though I have 13 resources, there are only 5 that are for that race, right? Which has the code of 2106-3, which is essentially white. If I search it, I should get only 6 resources now out of this, which is what the API call also returned. So that, I think that covers the second part of it, right? Let's look at the third part, which is the streaming export to BigQuery. And this is another configuration on the FHIR store or FHIR server, where we are indicating that, hey, FHIR store, whenever you get any mutation on it, any create, update, delete transaction that happens on the store, you write that to a BigQuery dataset. And BigQuery is more SQL-like. It's a data warehouse, so you can have a SQL-like access to your FHIR data. So let's look at that now. We look at our BigQuery right now. I don't have that FHIR store. I'll create a new data set in BigQuery, and then I will try to stream some data into that through FHIR store. So first, let's create a BigQuery data set. I'm creating a BigQuery data set. So I created a data set called R4_DS. Now, if I go to the BigQuery UI, I should be able to see that here in the list under my project. HA Portal is the name of my project. And in here, I have a new data set, which is empty at the moment. There are no tables, nothing in here, right? So what I'm going to do is I'm going to now configure my FHIR server. Again, how I configure is through patch. And we introduced the patch operation before. I'm going to do another patch call. And this patch call this time has basically added the BigQuery destination configuration for streaming config to my FHIR store. As you can see, my streaming config is enabled onto the FHIR store because I executed this HTTP patch call. And now what will happen is if I insert that patient again, Amy Shaw, that we inserted before, this time we will insert it with a new ID, new logical ID. And this resource should now be available into the BigQuery as well. So if I go now back here and search for patients, you see there are 2 Amy Shaw, the one that I just created, 1043, and this Amy Shaw's record should also be available in the BigQuery dataset. Take some time to bring it, but we'll look at it later on, because in the interest of time, I want to move on to ingest and harmonize CDA to FHIR. And for that, what we have is, we have in Google Cloud, you can bring in your CDA file, and I have a bunch of CDA XML file here, CCD, that we have generated using Cynthia from MITRE. We are going to insert this one of the CCD file into Google Cloud Storage, and there is a data flow job that we have written. So hold on. So we have written a data flow job that will take a CDA file, XML file from the cloud storage bucket, and it will convert that data from XML CDA to FHIR, and it will write a composition resource in the FHIR store. Plus, it will also write the linked resources like patient, observation, practitioner, organization, and so on into the FHIR store. So we'll look at that. I have already ran this pipeline once, but I'll see. Yes.
We are running out of time. Actually, we already ran out of time. Thank you, Kalyan, for answering so many questions in the Q&A tab. So unfortunately, we don't have time for live Q&A, but we already had some great questions there and some great answers. Feel free to use the Q&A tab probably Kalyan and Damesh can have a look at this. And thanks for this great presentation. And maybe we can continue the discussion or ask questions during the community events of the DevDays. So thank you again.
Thanks, everyone. Feel free to reach out to us on chat or on WOA. Thank you.
Thank you.